All right, let's look at the homework 3.3, problem number 3. All right, so we have this cubic function, and we want to find the interval on which f is increasing and decreasing. All right, so let's do that. All right, so we have to take the derivative. So f prime of x is equal to 3 times 2 is 6. Then you have x squared. And again, 3 times 2 is 6. X. And you have a negative 180. All right. So we can pull out, I guess everyone seems to have 6 in there. So let's pull out 6. Then you would have x squared plus x and minus 30. Right? All right, then we need to factor this guy out. So let's see, 6, it's going to be x plus 6 and x minus 5. Right, and I'm going to set that equal to 0 to find the critical numbers. So x is going to be negative 6 from here and a positive 5. Right, so those are the critical numbers. Right. Since f prime is defined everywhere, actually those are the only two critical numbers, right? So find the interval on which f is increasing. So we're going to have to do a number line there, right? Put a tick marks on at the negative 6 and the positive 5. Right? Then we're going to look at the sign of f prime, right? So let's do that. So we can try something smaller than negative 6. I'll try negative 7. Between negative 6 and 5, I like 0, so I'll try 0. And then after that, x equals 6 would be fine. All right, so let's look at this. All right, so you have, if you plug in negative 7, so negative 7 plus 6 would be negative there, right? Then if you put negative 7 here, negative 7 minus 5 is still negative, right? And 6 is, of course, this is positive. So positive times negative is negative. Negative times negative is positive. So you have a positive sign on this interval, right? And let's try 0. If you try 0, 6 is positive, right? 0 minus 5 is still negative. Positive times negative is negative. So it changes sign there. All right. And let's try 6. So if you try 6, so 6 plus 6 is positive, and 6 minus 5 is actually positive. So everyone's positive, so this positive here. All right. So which means that the original function f is going to be increasing on this interval and decreasing on this interval and increasing on that interval, right? So find the interval on which f is increasing is going to be, let's type it in. So it's going to be negative infinity to negative 6 and 5 to positive infinity, right? So let's type that in. All right, negative infinity to negative 6, and then you have intersect and 5 to positive infinity. I just put the infinity there, right? So that's where it's increasing, and the decreasing is between negative 6 and 5. So I'm going to go ahead and do that. So it's negative 6 and 5. All right, and find the local minimum and the local maximum value of f. So you can see that at negative 6, actually I have to go back here. All right, at the negative 6, right, it's increasing turning to decreasing. So we know that this is going to be a local maximum, right? And here, decreasing turned into increasing, which means that this is going to be a local minimum, right? So we need to find these values, right? So we want to plug in, so f of, right, -6, right, is equal to, right, so you have 2, oh, I don't like this, -6 cubed. What's 6 times 6 is 36, times 6 would be 6 times 6 is 36 again. 3 times 6 is 18, so 216. Right, so that would be -216. Right. All right, then you have plus 3 times. So it's going to be -6 times -6 is positive 36. So I can do that one. And then you have a -180 times -6. So it's going to be positive. Right, so 6 times 0 is 0. 6 times 8 is 48. And 6 times 1 is 6. So it's going to be actually 1080. Right? So that's going to be negative 432. Right? So this is plus 3 times 6 is 18. And 3 times 3 is 9, so it's 108, plus 1080, right? So this is going to be, so 1080 plus 108 would be 1188, right, minus 432, right? So 8 minus 2 is 6, right? 8 minus 3 is 5. Right, then 11 minus 4 would be 7. Right, so this is a local max is 756. Right, so 756. Right, then our local minimum is at 5, so we plug in 5. Right, so it's a 2 times. Alright, so 5 cubed would be 5 times 5 is 25. 25 times 5 would be what? 125. Alright, and plus 3 times 5 times 5 is 25. And a minus, alright, 180 times 5 would be, let's see, I'll just put that in for now. So times 5. Alright, so this is going to be 250 plus 75 minus, so let's see, so it's going to be 0. 5 times 8 is 40, and 5 times 1 is 5, so it's 900. So this is going to be 300, let's see, 25, right, minus 900 would be 575, right? So this is going to be 575. All right, then we want to find the inflection point. All right, so we need to take another derivative. So I'm going to do it here. So f double prime is going to be 6 times 2, so 12x, and plus 6, right? So then we set that equal to 0, right? So that will give us, right? So let's see, so 12x is equal to -6, and divide by 12, you get x equals -1/2, right? Because 6 over 12 is 1/2 with a negative sign, right? So here you can see that concavity actually changes. So if you do a number line here and put -1/2 here, right? Then you look at the sign of f double prime, right? So we look at something smaller than -1/2, so x equals, say, -1. So you can see that if you plug in -1, that's going to be negative. So we have a negative sign here. All right, after that, you can try x equals 0 if you want. You get positive, so you have a positive sign there. Right, so original function is concave down here. Maybe I should do a concave down. And here you have a concave up shape. Right, so let's answer that question. Right, so inflection point is going to be at, actually I have to find the value, so I'm going to just go ahead and put that it's a negative 1/2. All right, then we have to come up with the y coordinate. Oh, actually, the parenthesis is already included there, so I don't have to put that in. All right, we'll find that later. But here, interval on which f is concave up, right? So you can see that concave up after -1/2. So here, -1/2 and comma infinity. All right, then concave down before that, so it's going to be negative infinity, and then to -1/2. All right, so we just have to find the corresponding y value. All right, so you just have to plug in. So f of -1/2 would be, all right, so it's a 2 times negative. -1/2 cubed would be -1/8. Right? Plus 3 times -1/2 squared would be 1/4. Right? Minus 180 times -1/2. Right? So that would be, so this is -1/4 and plus 3/4. And this is going to be plus 90. All right, so this is going to be simply 2/4, which is 1/2, plus 90. All right, so this is let's see, 181 over 2. All right, so or 90.5, same thing. All right, so go here. Right here, 181 over 2. All right, so let's check the answer. Submit for testing. All right, it came back and looks like I made a mistake here. So everything else except for part B is I messed it up. So let's redo this one. So local max and a local min. Okay, maybe I reversed it. So it's going to be 756 here. So I'm going to write 756 here and 575 there. Right, let's see if this will fix it. All right, so let's check it again. All right, so that was one mistake. Actually, there's another mistake. So 575, I have to recalculate it. So let's do that. All right, so here we need to recalculate this guy. So it's going to be at the positive 5. So let's see if I did this correctly. So it's a 2 times, right, 5 cubed is going to be, so 25 times 5 is 125. So this is correct. And here 3 times 25. So this is correct here. And a minus 180 times 5. All right, so this is right, and here we have 250, so that's correct, and that's 75, that's correct, and a minus, so 5 times 0 is 0, 5 times 8 is going to be 40, times 5, 900, so that is correct. All right, so then we have, so 250 plus 775 would be 325, so that's correct. And then you have minus 900 is going to be equal to 575. So that should be correct. Let's see, what did I type in? 575. So this is wrong. Okay, so let me come back to this. All right. I was forgetting the negative sign, right? So let's fix this one. All right, so this was negative. All right, I'm pretty sure you guys already knew what was going wrong, but here, let's double check. Alright, it came back and we got this one correctly finally. Alright, sorry about a couple of mistakes, but we got them all done. Alright, that's it. I hope that this was clear.